Hello and welcome to this video. In this video, I'll show you how I built this coding editor. It's a desktop application that uses an AI agent to scaffold a React Native project. With the application, we are able to generate React Native code and preview the generated code using Expo Snack. This video will be part of a series where I show you how to build a desktop application using Tauri framework. All right, so here is the application in my Visual Studio Code. I have Tauri framework part of the application running here. And then I have my backend, Python backend running here on port 8000. So this is the page that you land on when you run the application. You land on the configuration page for you to set up basic configuration. So I'll provide my username, and then I'll provide the API server username. This is the API server where your AI agent is located. So that's the server here, port 8000. So I'm going to provide that HTTP localhost 8000. Then next, collaboration. So this is the server I'm going to use for collaboration when we handle collaboration in a later video in this series, but I won't bother about it right now. So the next section is AWS storage. So this is the credentials that we are going to use to upload files to AWS. So there's a feature in the application that allows you upload images that the AI agent should use as design inspiration. So those files I created it in such a way that we'll upload it to AWS storage, your AWS bucket. So this is where you just provide your access information, your credentials, basically. So I'm going to provide my credentials in here, and then I'll click on Save and Next. So US East 1. Then my bucket, I'm going to use YouTube. It's my bucket. All right, so save and continue. Great. So here is the default home page that you land on. So right now I don't have any project, so I'm going to go ahead and create a project. So let's create a project. So a new project. Let's say I want to create a music player application, right? Let's call it music player. Music player. And then I select the working directory. I'm going to use this working directory. Then I'm going to describe what the application does. A music player application like Spotify, but with a social feature to allow my friends see the music I am listening to. So let me use green, right? So I'm just calling the music player. I don't have any image right now, but if I had an image, this is where you just click on it, you select the images, and then you will use the image as inspiration. But I don't have any image right now, so I'll just click on Generate Project, and okay, so starting the AI agent. All right, great. Starting the agent. You can see we have some projects here. This is a template project that we just copied into the music player directory. So just template project for now. So the AI agent is scaffolding and generating the files. Great. So it generated all these files. Great. All right. So the AI agent is done scaffolding the application. So right here, you can see all these squiggly lines. The reason is in this template code that I have here, I deliberately didn't want the application to copy node modules, so I omitted node modules. That's right, all this, yeah, these red squiggly lines are here because there's no node module. So it's just telling you the module is not available. It's deliberate because I didn't want it to copy node modules into this folder. All right, so let's try to run it. Let's try to run the application. I'll click on run. Great, so we have the QR code ready. So I'll try to scan this QR code on my phone. So on your phone, you have to install Expo Go. So Expo Go is the mobile application that you can use to, scan your Expo, your generated QR code from Expo, and then you can preview it on the app on your phone. So I'll scan it on my phone, and then I'll just screen record my phone, and you'll see the application. All right, so I ran into an issue here on my phone, and I'm going to correct it, and I'm going to correct it here. So the issue is on home.tss. Home.tss, we have an issue on line 23. Line 23 in here. Oh, this is the issue. So it's not able to, okay, so it's having issues with the type here. So I'm just gonna put any. So to have a type of any. So save that and then run again. So publish again. Then I'll come back and I'll scan the QR code again. Then great. You can see now it works. You can see we have the UI, you have the application. You can see the player. It looks a whole lot like Spotify, right? You can see friend activities. You can see, okay, yeah, because that was what I told the agent, like, let my friend know the music I'm listening to. Yeah, great. Right, so that's the AI, the AI agent. Like, it was able to generate what we wanted. Now some images are broken, but we can easily just fix that in the code. All right, that's the demo. So the scaffolding agent generated what we want, and we are able to publish to Expo Snack, and we are able to, scan the QR code and see the application, working in the code that it generated. So in the next video in the series, we are going to wire up the editor agent, and we'll be able to, tell the AI agents to, like, you saw me fixing the issue in that file just now. So I could just, select that file and then tell the editor agents to fix whatever issues we have in that file. All right, here is the basic architecture of the application. I'm using Tauri. Tauri is a framework that lets you build desktop applications using web technologies. In this particular application, I'm using React for the front end, for the UI and the user interface. And then for the back end, Tauri uses Rust. So to connect the front end to the back end, so if on the front end you need to perform any system operation, right? Like, you need to access system resources, Tauri basically bridge that communication through IPC, inter-process communication. So it's kind of like a bridge that that connects the front end to the back end. So on the front end, I basically just invoke commands. So they are basically Rust functions that you invoke on the front end, and then the Rust backend performs the action within those commands and then returns the response back to the React front end. For this application, I moved all my HTTP requests to the Rust backend, which is the architectural pattern that Tauri advocates. So all my requests are on the backend, and all my HTTP requests I moved to the Rust backend, and then I make the calls from there to my server, which is a fast API server where I have my PydanticAI running. And then once the AI is done performing, whatever action it needs to perform, then I stream events from there back to the Rust backend, right? So I'm using server send events from there. I send the events back to the Rust backend, and then from the Rust backend, I send the response. I emit events from the Rust backends to the React frontend, and then you see the display there. All right, so here's the code. I have the Tauri desktop code inside the app folder, and I have the FastAPI Python code, the code that has the AI agent inside the backend folder. And so I'm going to walk you through the generate project flow. When you click on the generate project button, the flow that it goes through till the AI agent fully scaffolds the application, the project. Let me walk you through that flow. So first, inside the app folder where we have the Tauri desktop code, you can see inside SROC, we have the React code app.tss. All those components, they are React components, which is the front end part of the application. And then we have the SROC Tauri. This is where we have all the Rust backend code. So these are the code that we use to access system resources and do stuff on the backend. So it's all Rust. You can see build.ros. So they are Rust code. So inside SROC, when inside this prompt.tss, this is the component that handles the display, like that particular new project page is handled by this particular file, this component. So I'll go into the component, and then you can see prompt component. Handle create project. So let me show you handle create project. So this is the button, generate project. So when you click on that generate project button, on click, we call this handle create project function. So inside the handle create project function, we have these 3 steps. First, we create the project from template. Now, I have a barebone Expo project that I created and I'm using as template. So when you click on generate project, the first thing I do is to copy the content of that template project into the project directory. So the project directory is the project name that you gave on the page, right, becomes the name of the project. So we use that to create the project for you, the project directory for you, and then copy the content of the template barebone Expo project into that project directory. Then the next step, we go into that project directory with the content that we've copied into it, and then we build the file tree from there. So if you see on the Explorer sidebar, we have the folder icon. We're able to identify folders and files. So we have to build that and load it into Zostang. I'm using Zostang for my state management. So I build that and just capture the folder names and the file names and just build the tree out of that, the names, the folder, and the files. Just build a tree and then have it, properly represented on that sidebar. So that's what I do on the second step. And then on the last step, this is where we'll call the backend API. We'll call the AI agent to, generate all the other content and files that the application needs. So you can see in here, this is the command that we use for the first step, create project. So Tauri gives us an invoke function. So with the invoke function, we invoke a backend Rust command. So this is a Rust command, create project. I'll show you. So we invoke that command and we send this parameters to the command, and then the command does the copies the content of the template directory into our project directory, and then returns the project directory path. And then with the project directory path, we go to get file. We call the get file tree command, and then build the file tree, right? Build the file tree, and then this is where we then call the backend. So we call the backend. Let me show you this. So we'll call the backend side agent service. So you can see invoke run agent. So we'll call, this is another command, call the run agent, passing all the project path, the prompt, the app name, the brand color, and image URL. So this is where we'll basically prepare the payload that we use to call the API backend. And then once we make that call, we then set up a listener. So we see this Tauri gives us a listen function. So we then set up a listener, and then we listen for all the events that the API backend emits, because we're basically streaming events from the FastAPI backend. So all the events that are streamed from there we stream the event from there, it goes to the Rust backend, and then the Rust backend emits the events to the React frontend, and then we treat all those events right here. So this is where I treat all that. All right, so let me show you this create project. Let me show you the Rust code. Let me collapse this. All right, so let me show you the entry. So we have an entry main.rs, that's rs Rust. So inside this main, you can see the main function. This is the entry into the project itself. We have this run. So run is coming from this lib.rust file. So in here, so run. And in run, this is where you can see this invoke handler. This is where we define all the commands that we are using in the application. And there you can see we have create project. So create project is in the module, it's in the project module, which is a module project. So I'll go to the project module and I'll show you, let's search for create project. So there you go, create project. So you can see create project, the command, right, is basically a public async function. So it's just an async function. So you can see right here in the parameters, we have name and working directory. Now, immediately you will see that this working directory is in here, is represented as snake case, right? But in the React frontend, we are sending it as camel case. Now, what happens is Tauri does the conversion for us. So Tauri just converts it from camel case to snake case, right? So that's that. Let's get into the code. So you can see here, right, project directory, right? We are creating a reference to the working directory, and then we are appending the project name as well. So that becomes our project directory, right? You can see. Then we have the template directory. Remember the template thing I spoke about? So here we have the template, right? Inside this resources folder. Then we have the Expo. I have the Expo template. We have the barebone React Native project. We just have layout.tss, just one file. So that's that. So here we'll create a reference to the template directory. Now for Tauri to be able to access this template directory, you need to make Tauri aware of this particular folder so you can include it in the build. So here in the Tauri configuration.json, inside resources, you can see a list of paths to include. You need to provide resources Expo. That's the Expo template. So that's where I added it. So Tauri can include it in the build. So you can see template directory, right? Then we copy the content of the template directory, which is, you can see this copy directory recursive. Let me show you that particular function. So it's a function, see it here, right? The source is the template directory and the destination is the project directory. So we just copy recursively until we copy every content within the template directory into the project directory. And now there's this thing I'm doing here, ignore directory. So in ignore directories, I'm just letting I created a list of the modules that it shouldn't copy. So for example, if we had node modules in there, let me show you this ignore directories. You can see ignore directories up here. So I'm ignoring node modules, VS Code, Expo, Git, and all this. So it shouldn't copy any of this. That's why when we scaffolded the project, you could see those red squiggly lines, right? Which was telling you the module is not available, because I intentionally I didn't copy node modules and all these other things in there. So that's why. So let's go back to this. right? So create project, right? So we're here. So we'll copy the content of template directory into project directory. And then in this place, I'm replacing the name, which Expo template inside app.json, and I'm doing the same inside package.json, right? Every place where we have the name that we have the Expo template as name, I replace it with the project name. Let me show you what I'm doing with package.json. So in here, package.json, you can see we have the name of the template as Expo template. So I'm replacing it with the name of the project that we are scaffolding. All right. So after that, we return the project directory, which is what you see here. So we return the project part, the project directory, and then we send the project directory to the get file tree. We use that to build the file tree that we display on the sidebar. And then after that, I call the run agent, and then handle all the HTTP call to the backend and stream all the events from there to the React frontend. All right, so that's the code. Let me show you the AI agent on the backend. So let me collapse this. So on the backend, let me close all this. On the backend, you can see I'm using Poetry for dependency management. I have the main.py file. So inside the main.py file is where I basically set up my FastAPI, and then I have the generate endpoint, which is the endpoint I call to handle I call for scaffolding and generation. So I call the generate and I pass in this scaffold request model. So let me show you this model. So you can see the user prompt, the app name, the project path, brand color, and images, right? That we're going to use that the AI agent we use for design inspiration. And so I get all that. I prepare the dependency, the AI agent dependency, and then prepare the prompt. And then in here, you can see streaming response. I'm an event stream, right? So that's what I'm using. So I go to stream agent, which is this function in here, right? You can see I have an event queue. And so I set up the scaffolding agent, and then I call agent.run. So when I call agent.run, then I then in all the events that have been so let me show you one of the events, which is the file write event. Let's go to scaffold agent, right? Scaffold agent. So you can see this is scaffold agent inside the agent folder, scaffold. So inside the scaffold agent, you can see it's a class. And in here, I'm setting up the agent instance from Pydantic. So you can see I pass in the agent dependencies, the dependency type. So the type should be of agent dependency, and then the system prompt. And then in here, I have the tool, which is the write file tool. So in the write file tool that I'm making available to the AI agent, in there, you can see this is where I set up the event queue, and then I set the type of file write. So I'm telling the AI agent to use this write file tool, right? When it's trying to scaffold a project, right? It should use this write file to give me the content and give me the relative part of the file. So it returns the relative part and then it returns the content. So that content, I set the part and then I set the content, and then I create the payload and add it to the event queue. And the event queue is then processed inside here. You can see queue.get. So set the reference to the event queue here rather. And then we set the reference to the event queue, and then we'll process the queue. So this is where we essentially just process the queue, and then we yield the data and then send it over to the Rust backend, and then the Rust backend handles everything and then sends it to the React frontend. So the Rust backend will get the content from here and then get the relative part and then create that file, like with the relative part, create the file in the folder and write the content from the AI agent into that particular file. So that's the agent. Let me show you the system prompt. So here's the system prompt. So you can see the system prompt is basically you are an expert React Native engineer, right? That's the persona that I give the agent. And then I give it a bunch of constraints. So most of this constraint, I had to use Claude, right? Because I wanted it, the prompt, I just basically told Claude to make it production ready. So I had the initial draft of the prompt, but then I felt like it wasn't comprehensive enough. So I gave it to Claude, and I told Claude to, to make it production ready. And Claude gave me all the constraints and everything. So you can see I'm giving it an example layout file. And this layout file is the layout file that I have inside the template. Inside the template in here. That's the content of the layout file that I have in here. So what I'm doing with this, because I know people might want to generate, people would want to generate different kind of applications, right? So I want the AI agent to be able to use different font, right? It should use the font that matches the design, whatever the app is that the a user is trying to generate, right? It should use the font that matches that design. So I had to give it a reference and to let it know what the content of the layout file is and what it should generate. All right, so that's all for the AI agent and for the backend. In the next video, I will work on, so this is the scaffolding agent, right? In the next video, you can see in here, I have this edit, right? So we'll handle the edit agent, which is up here, editor agent, right? I already have like few files in there, but I really have not done anything with it. So in the next video, we'll handle the editor agent. So the editor agent, if you notice in the demo, right, you saw I was manually updating content within files, right? So the editor agent with the editor agent, right, the editor endpoint, you'll be able to select the file, right, and then just write your prompt like, hey, fix whatever issues are in this code, and then maybe give it the stack trace, and the agent will be able to use that to correct the file and send it back to us, and then we'll rewrite it and update the content of of the file, and then run it again. All right, so that's what we'll handle in the next video. All right, so that's all for the code. If you found value in this video, kindly like and subscribe to the channel, and I'll see you in the next video.